7:43 here in Kiwi.
The Radio Wammo Breakfast.
Let's steer into the night sky. Dylan Storey is our man from the Auckland Stardome Observatory. Hello, Dylan.
Hello, Wammo.
And first up this morning, we're covering the Planetary Alignment, which can be viewed in the morning sky.
Yes, there is a planetary alignment, so if you've been noticing strange things going on in your life, you can rest assured that it's got nothing to do with this planetary alignment.
Good, it's good, good to clear that one up straight off.
Yeah, because as we've talked about before, they happen, some sort of planetary alignment happens almost every year or every couple of years. But at the moment, there's a pretty good one. Most people haven't seen it, though, because it's up. Well, I'm certainly not the sort of person that gets up before sunrise if I don't have to. But if you do, you'll see it over in the east, a lineup of 4 planets, all looking quite bright.
Mm.
So Mars, Jupiter, Venus, and Mercury will all be seen on the eastern horizon just before it gets light.
And so will they all be clustered?
Okay,
I was going to say they're all clustered together.
They're all clustered together in the sort of area that you could block out the area of sky with a few fingers. So that's how that's how narrow a area of sky they're taking up at the moment. And will you be able to tell the difference between them? Well, yes, probably. Venus will be the brightest, and a kind of a whitish light that comes from Venus.
Mm.
Mars has obviously got a reddish tinge. It'll be one of the dimmer ones. Mercury will also be that's a kind of whitish light. It'll be one of the dimmer ones. And Jupiter, in really clear viewing conditions, you can see a kind of a yellow-orangey hue to Jupiter. But because we're going to be viewing this as it's starting to get light, Jupiter will probably just look like a dot in the sky.
Mm.
But either way, I mean, there'll be 4 planets will be easily recognisable as not stars, but something different and something to notice. So for all the people that get up,
well, that's fairly exciting. Of course, if you've got a smartphone, the handy thing to do to orientate yourself, figure out where all this is happening, is get Google a sky map on it, and and before you head off to work, if you're heading off early, and check it out.
Yeah, a lot of people are getting those now, eh?
Yeah.
And there's Apple versions of them too. And so point it towards the east, basically, towards, if you're in Auckland, towards East Auckland. And you'll find them. I always advocate sort of trying to find things without the use of the technology first.
Oh, go on. Why? Why when it's there and it's available to use?
Because if you always rely on the technology, you'll never actually sort of get that understanding of the sky, of how it works. You'll always be like, oh, where's that star? Let's find it. As opposed to thinking, it's mid-May, we're coming on winter, this constellation will be in this area of the sky at this time, sort of thing, and actually figuring out how the sky works.
Okay, well, moving along, let's look at the Crab Nebula and some flares that have been spotted.
Yeah, so just to cover what the Crab Nebula is, it's in the constellation Taurus, and it was discovered to be a nebula, I think sometime mid-last century, that there's this big sort of nicely patterned, colourful cloud of gas seen through a very powerful telescope. And it was detected that in the centre of it there is something flashing a very fast, regular signal at Earth.
Oh.
And it was sort of thought, well, could this be evidence of intelligent species? Well, no, it's not. But what they found was almost as interesting. It's actually what it is the core of an exploded star, something called a neutron star, otherwise called a pulsar.
Yeah.
And so this is a lot of mass condensed into a very small area, and therefore its residual inertia has caused it to be spinning incredibly fast. And any energy that's left in it, which is nothing compared to that of a star, but still, because it's so condensed, it's giving out energy. Much of that energy comes out the poles, and because it's spinning, the poles are wobbling. You've got these kind of beams of energy coming out the poles on both ends. And if Earth happens to be in line with these poles, which it is with this one, then we get these regular blasts of energy. And the Crab Nebula is one of the strongest sources of this this constant radiation flares. And
could we benefit? Could we benefit from this? Could we benefit from, I don't know, an extra showering of gold?
No, I mean it's a powerful source of radiation, but nowhere near that powerful. Compared to what we're getting from the sun, it's sort of millions of times weaker, billions of times maybe. But compared to the things that are out there in space that we measure and observe, we're getting a fairly high dose of radiation from the Crab Nebula.
And where can one go and observe the pulsar going on, the nebula going on there in the sky?
You can't really observe it. You can't really see a pulsar because it's not really giving out light. It's just giving out these gamma ray flares. So it can be detected, but it can't be seen. The Crab Nebula can be seen. If you Google it, you'll certainly see all these brilliant images of it's called a planetary nebula, meaning it's sort of come out from around the star in a planetary sort of fashion. Through the Stardome's big telescope, you would probably see the Crab Nebula at a good time, but because the sun is very near Taurus at the moment, it's not a good time at all.
Okay.
Probably the best time to view Taurus would have been a couple of months ago, so probably wait till next summer actually to view Taurus.
Okay. All right. Moving along, finally looking at the finding that solar system's planets may orbit in different directions, which is not the same as what's going on with our solar system, is it?
No, that's very different. All the planets in our solar system all go around the sun the same way, and they all except one spin the same way. All except Venus spin in a corresponding motion to their orbit. But I've talked a bit about the Kepler satellite before and how it's discovering a lot of extrasolar planets around other stars. So one of its latest discoveries is that some of the planets in other solar systems seem to actually be orbiting the wrong way compared to the other planets and to the spin of the star.
Huh.
And that kind of turns our theory of how solar systems are formed on its head a little bit, because we sort of think of a gas cloud, a nebula cloud collapsing. As it collapses, it's got residual spin.
Yeah.
As anything collapsing does, just like water going down a plug hole. And eventually, as the heat generates and starts a nuclear reaction at the core, then that forms a star. Star starts burning. Any clumps of gas around the outside that are gathered together enough to resist the new star's radiation pressure will clump together and form planets, and they'll all be spinning the same way from the cloud. So we're thinking, well, how could they be spinning the other way?
Yeah.
So I think the guess that's been come up with from the scientists involved is that it's caused by peer pressure. So basically,
isn't everything?
Yeah. Basically, the big planets, the big bullies of the solar system, are setting up sort of gravitational tidal forces, which can eventually get so strong that they can actually stop a whole planet's motion and cause it to go backwards around its star.
Wow.
So, though we don't see this with planets in our solar system, we do see it with some moons of the outer solar system. So there are some moons which are going in a retrograde orbit. So it is possible for this to happen. And it certainly changes our view of solar system dynamics in other solar systems.
Indeed. Well, that's some absolutely fascinating stuff. Dylan Storey, of course, people can go and check some of this stuff out over at the Auckland Stardome Observatory. We look forward to chatting to you next week. See ya.
Yes. See ya.
Dylan Storey there. And a track now.